The topic is the chain rule for functions of two variables with one independent variable. So let's read the definition. If z is a function of xy and x is a function of the independent variable t and y is the function of the independent variable t. See, these only both x and y are functions of the same independent variable t. In that case, dz dt, derivative of z with respect to t, is equal partial z partial x dx dt. So let's write it here. dz dt is equal partial z with respect to x times dx dt plus partial z with respect to y dy dt. Alright, so this is going to be equal to. So the first thing we need to do this example, this is our z function. So to find dz dt, we need to find partial z with respect to x. So let's do it here. So partial z with respect to x is equal partial z is 3x plus 2y e to the y with respect to x. Now since e to the y is a constant, I can take it outside. Now partial with respect to x of 3x is 3, of 2y is 0, so this is going to be just 3e to the y. So I'll take that and plug it into here. So it's 3e to the y. Now next thing I need is dx dt. So dx dt is, here is x, derivative with respect to t of 3t, which is 3. So I plug in my 3, plus. Next thing I need partial z with respect to y. Partial z with respect to y is going to be equal partial with respect to y of z. My z is 3x plus 2y e to the y. Now this time I have to think of this as f and g. So I'm going to use product rules right there. So this is going to be equal partial with respect to y of 3x plus 2y times ey plus partial with respect to y of ey times 3x plus 2y. And this is going to be equal partial with respect to y. 3x is a constant, so it's 0. Derivative is 0, so it's just 2. So it's 2e to the y plus partial with respect to y of e to the y is just e to the y times 3x plus 2y. Let me rewrite it here. So this is going to be plus 2 plus 2ey plus ey factor of 3x plus 2y. We want all this times dy dt. So what is dy dt? dy dt is derivative with respect to t, here's a y, of 2 minus t cubed, which is just minus 3t squared. Now last step, I need to kind of like multiply things but replace the y by its value and then the x, each x by 3t. So let me rewrite it here. So 3 times 3 is 9. So this is going to be 9e. Y is 2 minus t cubed. I mean, look at it right there. Plus, well, let me distribute this so it'll be easy. Well, let's leave it last. So plus 2e, my y happens to be 2 minus t cubed, plus e, my y is 2 minus t cubed, times 3, x is 3t, 3 times 3t is 9t, plus 2 times y, 2 times that. I'm just going to distribute it. Hold on. yeah, 2 times y will be 4. Let me do it in 2 steps. So 2 times my y will be 2 minus t cubed. So I can afford one more step. 9e 2 minus t cubed. How do I do this? Let me distribute this minus 3t squared. If I multiply it here, this is going to be minus 6 t squared e 2 minus t cubed. And then I'll multiply it. Let me do this. This is 9t plus 4 minus 2t cubed. Then I'll multiply it by this one. Plus, let me do this. And put e 2 minus t cubed on this side. So minus 3t squared times 9t will be, well, let's write it from the highest degree, times minus 2t cubed will be 65, so 65 times 9t will be, I'm just distributing, minus 2073 minus 12t squared. T squared is inside the parentheses. And that's it for that example. So let's do the next example. Next example, same way. We need to calculate dz dt, which is partial z with respect to x, dx dt, plus partial z with respect to y, dy dt. Again, we start with partial z with respect to x. Partial with respect to x of z is the same thing as partial with respect to x of cosine of xy, which is, remember the y is, we need to use this formula. So we need minus u prime sine of u. So minus u prime in this case will be partial with respect to x of the inside, right? And then sine of u, sine of xy, which is equal, y is the constant, so minus y sine of xy. So this is partial z with respect to x. Let's do all the way, plug in the t and y so we don't have to do the work twice. So let's plug in, well, no, let me leave it this way. Now next we need to do partial z with respect to y, which is partial with respect to y of cosine of xy. I mean, everything is the same way. Instead of x is a y, instead of y becomes x. So this becomes minus x sine of xy. Now next thing we need to do dx dt. Dx dt is equal to t, and dy dt is equal to minus 3. That's easy derivative. Now therefore, let's call this number 1. dz dt is equal, partial z with respect to x is right here, minus y sine of xy times dx dt, where is our dx dt, 2t, plus partial z with respect to y, which is right there, times dy dt, which is right here, times negative 3. Now all we have to do is plug in these replace y by its value and each x by its value, and then try to multiply these things. So this is going to be equal minus 2t. My y happens to be 2 minus 3t. What is this? Yes. And then sine of x times y. This is x, t squared, and the y is 2 minus 3t. Plus, minus times this minus becomes plus. So 3. X is t squared. Sine of xy, same thing, t squared, 2 minus 3t. One more step and I think we should be done. dz dt equal, let me distribute here, I'll get minus 4t plus 6t squared. Sine of, let me distribute also here, 2t squared minus 6t cubed plus 3t squared sine, same thing, 2t squared minus 6t cubed. And that's it, that's the answer.